In this demo, we're going to walk through the BricsCAD Mechanical designed for manufacture and assembly optimization and validation workflow. By integrating DFMA studies into BricsCAD Mechanical, our users can enhance efficiency by identifying cost-effective design changes early, reduce manufacturing complexities, minimize assembly time, and ultimately optimize product manufacturability and assembly processes. In V24.2, we've made some updates to the BM Assembly Inspect feature, which enhance the following workflow. These include expanding the assembly inspection methods by adding gravitational stability, and simplifying the assembly optimization workflow by refining the command panel. Let's open an existing 3D model and start the workflow. First, we're going to create an assembly sequence using the BM sequence command. We create build steps which mirror the sequence in which components would be assembled in the real world. Now we move into the inspection phase of the workflow. We run the BM assembly inspect command. This feature is still in beta stage and is being continuously improved. Today, we're going to focus on the tool usage and the new gravitational stability aspects of Assembly Inspect. Tool usage evaluates whether tools have a sufficient range of motion in reference to their position within the assembly at a given sequence step. The idea of gravitational stability is to verify whether the component would be gravitationally stable before fixing the fastener. It's mostly for ergonomic reasons. If it is stable, even without fasteners, the assembly person can use both hands to pick a fastener and a tool. Gravitational stability is new to Assembly Inspect. However, we've also made changes to the feature dialog, putting everything in one place. By opening the Assembly Inspect settings, we can add the tools required for evaluating the assembly. With BricsCAD Mechanical V24.2, there is a standard toolkit supplied with the install of the software. There is a possibility of customers using their own specialist tooling and adding these to the study. Once the required tooling has been added to the study, we can now map the specific tool to its corresponding fastener or fitting. This is done via the routine editor dialog. Once we've selected the assembly sequence we created earlier, we can see all the steps appear with options to study individual parts and testing criteria. With the test run, we now see the results. The new dialog UI efficiently and easily displays the results within each step and with each testing criteria. It also gives an overall result based on the individual criteria results. We can see that in step 1, in regards to the tool usage criteria, the fasteners are completely unrestricted, and the same is true for step 2. However, both these steps raise possible issues for gravitational stability, whereby the part has been classed unstable in the fall criteria. This result indicates that special attention needs to be paid to the orientation of the assembly at these steps. Step 5 has raised a potential issue in terms of tool usage. 2 of the fasteners only allow for 25 degrees range of travel. This result would indicate a possible design change to allow for more travel. Overall, the results of the Assembly Inspect feature should be used to verify the design and the assemblability of a product. It should be used to highlight potential corrective action measures, which can come in the form of design changes, identifying the most efficient assembly and tool orientation, as well as the steps which will require special attention from the technician. In this updated model, we've taken corrective action measures based on the original test results. We will now rerun the test on the new model. By adding a hole on either side of the mounting bracket, we have been able to improve the tool range of travel at step 5 to 85 degrees, a drastic improvement compared to the original design. In this workflow demo, we've shown that with BricsCAD Mechanical, you can optimize and validate your assembly designs with our Assembly Inspection Workflow Toolkit. At BricsCAD, we continue to innovate and update our features, like here in V24.2, where we introduced the gravitational stability criteria to assembly inspection, as well as an updated feature dialog to create a more seamless workflow.